you, and today I'll be discussing about hypothesis testing using traditional method and p-value method. Hypothesis testing is a statistical method applied in making decisions using experimental data. Hypothesis testing is a process that helps us make decisions using data. It's used to check if a certain claim or statement about a population is true or not. We always start with two statements. First is null hypothesis, which is no effect and no difference, and alternative hypothesis with effect and differences. Traditional method involves formulating null and alternative hypotheses, calculating the test statistic and critical values based on a chosen significance level and comparing the test statistic to the critical value. In this method, we compare a value we get from our sample, called the test statistic, to a number from a statistical table called critical value. If our test statistic is more extreme than the critical value, we reject the null hypothesis. If not, we fail to reject. Left-tailed test. Reject the null hypothesis if test statistic is less than critical value. Z is less than 1.645. Right-tailed test. Reject null hypothesis if test statistics is greater than critical value. Z greater than 1.645. Two-tailed test. Reject null hypothesis if test statistic is less than critical value or greater than critical value. Z less than negative 1.96 or Z greater than 1.96. We have two formula which are the t-test and z-test. T-test is equals to sample mean minus population mean over sample standard deviation divided by the square root of sample size. Z-test is equals to sample mean minus population mean over the population standard deviation divided by the square root of sample size. P-value method is a statistical approach used in hypothesis testing to determine the significance of a result. So here we find the p-value which tell us the chance of getting a result if the null hypothesis were true. If p-value is less than our significance level, we reject the null hypothesis. So if p-value is greater than our level of significance, we fail to reject our null hypothesis. Both method helps us decide whether to accept or reject a claim based on our data. The traditional method uses critical values, while our p-value methods uses probability, but both lead to the same decision in the end.
After discussing the two methods, here are the sample problems. The average weight of all residents in town XYZ is 168 pounds. A nutritionist believed the two men to be different. She measured the weight of 36 individuals and found the mean to be 169.5 pounds with a standard deviation of 3.9. At a 95% confidence level, is there enough evidence to discard the null hypothesis? Before ta mo proceed sa atong solution, state sa nato ang null and alternative hypothesis. Null hypothesis mu is equal to 168. Alternative hypothesis mu is not equal to 168 and sample size is equal to 36. Sample mean 169.5. Sample standard deviation is equal to 3.9. Confidence level is 95% or 0.95. So, alpha is equal to 1 minus confidence level. So, isubstitute nato 1 minus 0.95 is equal to 0.05. Para ma-use nato ang traditional method, we should compare the calculated z-value with the z-value that's associated with the test statistic. Sa ato ang cumulative area from the left, i-plus nato ang 0.95 sa 0.025. Muna ang total sa atong cumulative area is 0.975. So 0.975 with the z value of 1.96 from the table. Now let's compute our calculated z-value. Z is equal to sample mean minus population mean over the population standard deviation over the square root of sample size. So we have Z is equal to 169.5 minus 168 over 3.9 over the square root of 36. So, ang total niya is 1.5 over 0.65. I-divide na to ang 1.5 sa 0.65. Ang gawas is 2.31. So, mauna ni ang calculated z-value. Since our calculated z-value is greater than our critical value, thus we will reject the null hypothesis.
This is Maria Marlene Macy Garcia, and I am going to discuss the p-value method. So we already know that p-value method is a statistical approach used in hypothesis testing to determine the significance of a result. So if p-value is less than or equal to alpha, we must reject the null hypothesis. If the p-value is greater than alpha, we must accept the null hypothesis, or we have failed to reject the null hypothesis. So we have the same problem here. The average weight of all residents in town XYZ is 168 pounds. A nutritionist believes the true mean to be different. She measured the weight of 36 individuals and found the mean to be 169.5 pounds with a standard deviation of 3.9. So here we have the given, the null hypothesis, mean or mu is equals to 168. Our alternative hypothesis is mean or mu is not equal to 168. Our sample size is 36. Our sample mean is 169.5. Our population standard deviation is 3.9, and our confidence level is 95% or 0.95. So, in order to get the alpha, we must minus the confidence level with 1. So, our formula is alpha is equals to 1 minus the confidence level. So, our value for confidence level is 0.95. So, alpha 1 minus 0.95 is equals to 0.05. So this is our alpha. So this is the value of our alpha. So this value is, we are going to use this in order to compare the p-value if we must reject the null hypothesis or accept the null hypothesis. So here we have the computed z value. So the formula for z is equals to population mean minus the mean over the standard deviation all over the square root of the sample size. So 169.5 minus 168 over 3.9 all over the square root of 36. So here we have 1.5 divided by 0.65. So we have 2.31. So this is our z value. So how do we know if we use two-tailed, right-tailed, or left-tailed? So for the right-tailed, if we must look for the sign in the alternative hypothesis. If the sign is greater than, we use right-tailed test. If the sign is less than, we use left-tailed test. And if the sign is not equal to, we use two-tailed test. So our problem here, our alternative hypothesis is mean is not equal to 168. So we use two-tailed test. So here we still have two-tailed test. But what I'm going to do is to put the calculated z value here, which is 2.31. So here we have 2.31. Here we have negative 2.31. So what we're going to do now is to determine the area of the shaded region. That total area, the right side and the left side that corresponds to our p-value. And we are going to compare it with alpha to see if we must accept the null hypothesis or reject the null hypothesis. So, ang gihimo ganina ni Miss Salapa is very important to determine the p-value. Now, we have the value for our z. So our z is equals to 2.31. So we are going to use the same table and get the area.
So here is the positive z-score table. Now, we have the z value and we want to find the corresponding area value to the left. So, we need to find a row with a value of 2.3 and a column with a value of 0.01. Because our z-score, if you recall, is 2.31, now the area value that intersects that row and column, as we can see here, is 0.98956. So, this is the area value that we want to use, which corresponds to a z-score of 2.31.
So, this area value, 0.98956, is the sum of this area plus this area. So, in order to get the area on the right, we must minus 0.98956 to 1. So, 1 minus 0.98956 is equals to 0.01044. So, this is the area to the right. The area to the right is 0.01044. And for the left, it is gonna be the same. So, 0.01044. In order to get the area in the middle, we must 0.98956 minus 0.0144. So the total is 0.97912. So this value is the area on the middle. So 0.97912. Now, the p-value is the sum of the area on the left side and on the right side. So, 0.01044 0.01044 times 2 or 0.01044 plus 0.01044 is equals to 0.2088. So 0.02088 is our p-value. So our p-value is 0.02088. So we must compare this value to our alpha to see if we must reject the null hypothesis or accept it. I say Gaina, if a p-value is less than or equal to alpha, we must reject the hypothesis. Since our p-value is 0.02 less than 0.05, so we must reject the null hypothesis since our p-value is less than alpha. So that's how you can do it using the p-value method. So we could say that with a 95% level of confidence, we cannot accept the null hypothesis that the average weight of all students in town XYZ is 168 pounds. So with 95 confidence, we believe that there is enough evidence to reject the null hypothesis.